Hello everybody. Welcome back to my channel. Um this is Web3 Protocol Africa Studies. Yeah. In these sessions, we take a concept and we try to break it down and try to explain this concept for ease of understanding, right? So not just taking this concept alone, we also discuss um, issues related to core development, also discuss topics related to protocol engineering and core development, right? So my name remains Emmanuel Ifediora, and I'm a blockchain enthusiast and a protocol engineer in this space. Yeah. So without further ado, let's jump right into what we have today. Yeah. So this is more like a continuation of what we talked about last week. So last week we were on the concept of Libp2p, and I told you guys that Libp2p is a library, basically a framework that is used to build peer-to-peer applications. Yeah. So Libp2p is basically a framework that is used to build peer-to-peer applications, right? So this protocol or this framework, as we all know, it was used in the Ethereum blockchain. So basically it was used in the consensus layer implementation of the Ethereum blockchain. So if you are to go to either, maybe for instance, the lighthouse client, which is the consensus client implementation that was written in Rust, or maybe you go to the Prism client, which is the implementation also that was written with Go, the Prism consensus client, right? So if you have to go to this client, definitely you're going to see an implementation of this Libp2p in their code base, right? Telling you that yes, this is Ethereum actually employ, or Ethereum actually make use of this Libp2p that we're talking about. Yeah. So without further ado, what I'm going to be doing today, I'm going to be walking you through a code base, a basic code base that I wrote, just trying to play around the concept of Libp2p. Yes. So let's dive right in. So yeah, let's quickly open up the Go Libp2p package. So let's see what it's all about. Right. So I came to go.dev. This is go.dev. Is where, so if you come to go.dev, click this, my network is acting up. So if I should click these packages, this here, I'm going to find any sort of package that is available in this go.dev web page. So if I should type the name of Libp2p, the Go implementation of Libp2p is go-libp2p. So if we should check that out here, if I should click this is actually the repo for the Libp2p framework. Here, as you can see, it says this is deprecated, this also is deprecated, so all of these are all deprecated, but this is the one still available. So let's open it up. Yeah, so this is the Libp2p library for Go. So it has different types, and it has different functions under it. So using these functions, you can sort of like create a peer-to-peer application. Yes. So using this framework in the right way, you can sort of like create a Libp2p, a peer-to-peer application. So with that said, let me open up my IDE. So I'm going to go to my work environment. I call it playground, since it's actually, I was just testing out stuff around Libp2p. So if I should ls, I'm going to go into Libp2p and I called it libnode. So if I should do code dot, I'll open up VS Code. Right. Yes, so this is my implementation of, this is just a basic stuff that I did. It's my implementation of the code base, right? So I'll just walk you through it and we'll just run and see what it gives us. Basically, I'm running this locally, so hopefully I get the expected output. Yeah. So first things first, when we want to generate a pair, or when working with Libp2p, you actually need a pair to be able to like communicate in the network, right? So first things first, I came here. This is a function that I'm going to be using to create what we call a key pair, right? So we have basically our public key and our private key. All of this is actually implemented in the Libp2p. Like I said, the Libp2p is basically a library that you can import into your own code base and tweak it as you want, right? So here I imported this crypto.generate key pair function from the Libp2p crypto package over here. So I imported it and I use it to create a key pair, a private key and a public key, right? Yes, so doing that, I call the function, I pass it the type of the key type that I want, which is ED25519, which is secure. It's a secure key type. Then I pass in the number of bits I want for that key, which is 4096. Then the output, the return values of this function is basically, it returns a private key, a public key, and an error, signifying to us with that error value we can tell whether if it actually returns the private key and the public key or it returns an error. So here we check if the error is not nil, that means there's actually an error. In Golang, this is how we undo errors. So if error is not equals to nil, that means there's actually an error. Then we print error generating the key pair. Then we print the actual error, and then we return nil values in place of the public key and the private key. But if that's not so, if error is actually equal to nil, that means there's no error. Then we return the public key and the private key. Yeah. So like I said in our last class, I talked about the pair ID. So I talked about how we could use our public key to generate a pair ID. Alright. So here I'm generating a pair ID. So I'm taking the public key, we can actually use both, either the private key or the public key to create our pair ID. So I'm using the public key. So I come here and I call this function the ID from public key, taking the public key, and it returns my pair ID. So with that, now I've gotten a pair ID for my node. So here I just check for errors and I return the pair ID. Then over here, basically this is basically an helper function. So I called it file existence. It just basically check for the existence of a file for me. I'm basically using it to check if, because over here, to make my application persistent, or to make this my, because I created a key file that will basically store my private key, so I don't have to create it anytime I start up the application. So it's actually persistent. I don't have to like change my private key often whenever I start my application, right? So that is why I'm having this file existence function. So here I check if I check the start of the file, the status of the file. So if it is available, it's going to return a file info according to Go, and an error. So it is with that error, and I'll check if the error, so okay, it's going to return an error, right? Then I call this function is not exist. It basically takes an error that was returned from the start function. So if it takes in that error and says is not exist, returns a boolean indicating whether its argument is known to report that a file or directory does not exist. It is certified by error not exist. So this basically checks the error. If the error talks about a file not existing, it returns a boolean value, either true or false. So here it just checks if the file exists. Now let's go to our main function. So over here, don't mind me, I was just playing around. I created a context to basically, because when you're working with a node, right, you tend to like listen for connections. So I created a context that when we sort of like when we listing on for address, so we are going to be listening on this address, the IPv4 0.0. It's basically, like I said, it's on my local machine. It's local host. So we're going to be listening here. When it prints, it's going to like still be active to keep the node running. So, but I use this context to like set a timeout. So when it's that timeout, my application ends, right? So the program ends. So let's dive right into what we have here. So I created a context and called with this context.background. So this context package is used. We have a function called background inside of the context package. So this background actually returns context.context, right? So this context is actually used for cancellation in Golang. So that's not the scope of our topic today. That's not our scope, but I'll just talk about it. So here I have a peer ID variable. I have my private key variable, I have my public key variable. So I set a timeout for our context. So this function with timeout returns a context and also a cancel function, right? It returns a cancel function. So here we defer the cancel function. So here is where our application actually starts. So if file exists, so we check if the file exists. If it does, we print key pair already exists. Then we try to read the private key, because it is the private key that was actually stored in the file, right? So we try to read back our private key from the file. So doing that, we read it in bytes because it's stored in bytes in the file. Then we check for errors. Then we unmarshal the private key back to because here the type of this private key is pref key according to the Libp2p package, right? So actually unmarshal it back to that type. We get our public key through the private key. We get our peer ID. That is if the file exists. So if the file does not exist, we create a key pair again. Then we get our peer ID. Then we marshal it and save it to a file again. Then we save the private key to a file here. We have to first marshal it. Then it says the marshaled value that we save to a file, right? Then we come out here and print the peer ID. Yeah, so this is the interesting part. So here we have to like get our node, right? Node command. So we use this new function, right? So here it says new construct a new Libp2p node with the given options, falling back on reasonable defaults. The defaults are: if no transport and listen addresses are provided, the node listens to the multi-addresses IP4, which is IP version 4, 0.0.0.0/TCP/0, and also IP version 6 here, which is the loopback address, also the same thing as 0.0.0 port 0, right? So here it says if no transport options are provided, the node uses TCP WebSocket and quick transport protocols. If no multiplexer configuration is provided, the node is configured by default to use YAML. So, and all of that. So here we call this function and taking our private key. Here we call the transport function and pass it the new transport. Yeah, a new TCP transport, and here we passing out the address we wanted to listen on. So it says here, I wrote the comment, listen on all IPv4 interfaces on port 9000. So after that, I check if the error value is nil. That means if it actually contains an error. If it contains an error, we print out this error message and we end the program. Then we close our node. This defer means it's actually closing the node at the end of the program, not when the program is still running. So first of all, we print the node ID, then we print node addresses, and we run a for loop on this addresses function that belongs to our node that we created over here. So we print each addresses that we could find that is on our node. Right, so here this select statement is used for channels. So here it's more like it's just like the switch case, where you have different cases and you use the switch keyword to basically do a select statement on each cases, right? So here, but this is basically for the select statement is basically for channels, right? So this case here, the time.after is going to return a channel of type time.time, and the context.done is going to return a channel also. So basically this select statement is for channels. So let's run our code to see what it prints out. Basically this is on localhost, so we are not expecting much from it. So go run main.go. Right, so let's see. Yeah, so it says key pair already exists, so we have our key pair here in this file, the node.keypair.pem. So it prints our pair ID, our node ID, and the addresses our node is listening on. So here I have my localhost address over here, which is 127.0.0.1/TCP/9000, which is our port. And here I have my my network connection address, which is 172.20.10.3. Yeah, so here it says context done, shutting down, which is actually because I gave it a timeout of 5 seconds, so it actually runs for 5 seconds and it shuts down. Yeah, so that's basically the little code that I wrote just to like have a feel of how Libp2p works. Yeah, and I hope that you're able to get at least something from this talk or from this session. Yeah, so please do well to reach out to me if there's any question on my X. I'll put that in the description section, or in the description section rather. So thank you for viewing. God bless you.